restriction in size. Another method is to store it in the file. We create a header to the file, like xvid for MP3s, where we can store a small amount of information, which usually is predefined. And last, we have the sidecar files, where we have the file with the content and another file with the data. We have a problem in the database with portability. When we exchange our multimedia files, the metadata stays with the database. We don't send the database. The in-file is portable enough, but have a small amount. And sidecar files, it's two separate files. It's not so easy to use. Okay. The video metadata, the standards that is used is qualified core, core, MP7, excessive metadata, and the XMP from Adobe. Why to use the video metadata in a metadata conference is a silly question, but help us to retrieve our multimedia by queries that users does. Metadata used by search engines, so it's more easy to discover. Video, we can improve our video management and enhance portability. Okay. Now we'll see the QR codes. Essentially, QR codes is quick response code. It's a two-dimensional barcode. We have the one-dimensional barcode. It's all we use it. We have seen it in all our products. Okay, but have this. It's numeric only. We have small capacity and can be scanned in one direction to read with the scan. Okay. And essentially, create a link. The ID creates a link to a database where the data stores. On the other hand, we have QR codes. It's two-dimensional barcodes. It's alphanumeric. You can store anything. We have a large capacity, 7,000 to the maximum version of digits, or 2,000 characters to version 40, we'll see about version later. Can be scanned in any directions with a camera, usually demands 5 megapixels or more. All of your smartphones can scan QR codes. Have already compression and error corrections, and it's ready. Okay. This is the structure of the QR. We have the required patterns, position, icon, and timing. Around it, we need to have a quiet zone. And the gray area is where the data and error correction key is there. Okay. And we have version information at the blue and at the red, format information. Okay. Let's see where the data is stored. Here is the message data. You can see it's from D1 to D13 and from D14 to D26. You can see this is D1, D2, D3. Okay. And the error correction is from A1 to A22 for message D1 to D13, okay, and E23 to E44 for the message D14 to D26. The method to embed our metadata is to use the least significant bit. imagine that this is a picture, and every cell it's a picture. This is an image, and every cell is a picture. The common representation of images is by using the RGB, red, green, blue. Okay, every color has one byte of information, 8 bits. For example, our color is this, is that numbers. And the binary representation is here. Okay. So if I change the last digit of the byte, we produce a very small noise. And this can be shown here. We have two colors, and we only change the grain from just from 127 to 126. Makes no difference to us, but there is. It's very small. And with that example, this is the original image, and this is the image after we embed the QR code to the least significant bit. A grayscale image, okay? There is no obvious difference. We can detect it. A computer system can, okay? So, by embedding to this significant bit, is steganography, is watermarking, or something else? To be steganography is the steganography is to exchange messages among trusted entities. I send a message that is encrypted to the file, and nobody knows except the receiver. It's they don't even know that we have a communication that way. Okay. In watermarking, we embed a secret message in order to prove ownership, the copyright, okay? Authenticate the media that is not altered in any way. And if altered, and where? There is application of watermarking for this. In our scenario, the data, everyone has access because it's metadata. We don't need to hide it. Okay. This is our proposal. We have a video file. Imagine the color components, RGB or something else. Okay. And in every component, we embed in the least significant bit the QR code. This is easy to do because the QR is binary. It's black or white, usually. It's 1 or 0, okay? And here we have a frame of a video and the 3 QR codes that we have embedded as metadata. The experiment we have in the experiment we have 14 video files. There are 300 training sheets, 12 seconds of durations, okay, and it's 7 files with this resolution, and the same files with the half resolution, okay. In every frame we embed 3 QR codes with 120 random characters. So every video comes about 105 kilobytes of metadata for 12 seconds. It's not bad, and it's not the maximum. You can, for example, in the big resolution, we can embed 4 QR codes. Okay. This is measurements for the quality. We compare the original video with the video that has QR. You see, it's very small, and the maximum difference is 1. because we change only one bit. Okay. One drawback is that the file size of the files after compression is now we have larger files, but that is not a problem, at least for many applications. Okay, by doing this, what features we have? Okay, small distortion in image, in video. The metadata is synced to the content because it's we embed the metadata in frames. So every frame can have different metadata. Easy encoding, fast decoding, survives lossless compression, and one thing is when we change file types, some supports metadata when in file, and some is not. For example, if we change an MP3 file to a WAV file, the MP3 tag will delete it. We don't have the metadata anymore. In this way, we can keep metadata when we have a file type conversion. Okay. Another feature is when we processing the video file, we can cut a scene and paste it to another video. The metadata in that scene travels to another video, to the other video. So we have the metadata in there. We can choose the metadata standard that we will use because we have enough capacity. And it's robust in some common digital processing if we flip or add text in a video or a logo, for example. And this is a screenshot while the video with the QR was playing. Okay. And this is the decoding of the screenshot. This means that it can be, for example, you see a video in a browser, but another application can use this metadata to do anything it likes. Okay. Okay. Now we have an image on the QR code. We embed this QR code the host image, and after adding text, it's okay. So we will introduce noise to the image, and this is the QR code that we recovered, and we can filter with a noise removal filter and have this. It's a new. Our proposal is a new way to store metadata. Okay, and we can use existing standards. The metadata stays syncs with the content. It's a frame based. Otherwise, to intentional removal, and have many features that the application can emerge from that. And thank you.
I've got two questions. First of all, can you apply any metadata standards to this?
Yes, depending on the capacity. The maximum capacity of QR is, if you want numbers, is about 7,000. If you want alphanumeric, it's about 2,000 something. So if but you can, if you have that problem, you can apply it to every frame, in 3 components, color components, red, green, and blue, and to another frame.
So it's only a matter of capacity, so you can use whatever you want.
Yes.
Okay, and the second one is, I was wondering if there are any